Good afternoon. Welcome back to Tracing. I'm Zaid and I'm your TA for today. Today I'm going to show you how to use the stack and how to trace a simple program in Java. So let's go ahead and go to the practice page. I have my starting code here. And you see we have my class and our main method. So just like how you would do in Python, you want to read the code from top to bottom, at least when it comes to the method, the main method. So first things first, you should always make a stack frame for your main. So you can go ahead, click to create stack frame, typed in main for our name. You see it turns a nice black color. And now we can start tracing the inside. So looking at this code, it does a couple things. We create a variable x assigned to 10, y is 25, and z is x plus y. And then we log it out at the end. So you want to make sure when you're doing these traces, you understand where things are going and why they're going certain places. So because we have three local variables being declared in main, we're going to have three variables declared in our stack frame. So we have x, which is 10, and then we're going to go over here to create a new variable. We have y, which is 25, and then you have z, which is x plus y. Now, you learned previously when you were learning Python that something like x plus y is an expression. But in a stack trace, we don't put the expressions, we put the values. So you would actually do x plus y, which is 10 plus 25, which is 35. So for z, we'd put 35. We would not put x plus y. So now that we have that, we see our last line is to print out sum of x plus y equals, and then z. So we can put over here at IO, we'll hit create IO line, and we'll type in over here, sum of x plus y is 35. You see, this is really similar to just running the code, and it's sort of like you're running it in your own head, looking at what the output is after each line, and sort of capturing that in your stack trace. So technically, this is a completely valid trace. Now, there's one thing that you have to do after finishing a method is you should cross it out. You see there's a big X right through it. And the reason we cross it out is to show that the execution of that method has finished and that we understand that this is what it's looking like after it's finished. So now you've traced your first program. I'm going to actually talk about something else as well. What happens if we reassign to a variable? So x is 15. We redeclare it to be 15. Let's uncross this out because we're not done. And let's comment the printing just for now. So by reassigning x to be 15, we have to go over here to where this plus button, it says update variable. We go ahead and click that and give it the new value, which would be 15. Notice how this doesn't affect z, which is still using the previous value of 10. You have to understand like where we're doing these updates. If this was, say, over here at line 6 instead, then that would obviously affect the outcome of z. But because it's down here, it does not affect z at all. So let's see how we put other type of variables. So stuff like strings, let's say string 1. The way we'd show that in our stack frame is we do create variable, do str1, and then for the value, we'd make sure that we put in quotes hi with an exclamation and then quotes around it, right? You got to have those quotes. If you don't have your quotes, you would lose points if this was a lab. You might notice that we have args up here, and something we previously said is that we always include parameters when it comes to doing stack traces and we're doing our stack frames. Args is a special case where we just sort of ignore it because it would be a little bit too complicated for us to trace, and we usually don't use args in any meaningful way. But for all the other methods, you would in fact trace it. All right, so we've gone ahead and completed our first trace. Let's move on to another example. All right, so we've gone ahead and started back with a fresh trace. You can see over here we have new code. Using my class, we have main, which declares a variable x to be 10, and then a variable z to be whatever the return value of my class dot something is. Now, you might not understand what this static or, even what this public stuff means yet. You don't need to yet. You'll learn about it later in the semester. All you need to understand is that this is comparable to how we did Python, where we can assign a variable to be the return value of a function, or in this case, a method. And we have this method over here called something, which takes in a parameter a, has a local variable x, and returns x plus a. So let's go ahead and start tracing this. We have our stack frame, and we call it main. We have x, which is 10, and then we go ahead and create a new variable, which would be z. Now, before we go ahead and give it a value, we need to trace the run of something, right? Because we don't have anything that we can put in value yet, so we should do the stack frame first and foremost before we put the value. So let's go ahead and create a stack frame, name it something, and now let's get started. So there's a variable or a parameter a, which we need to trace before we start doing the local variables. That's a very important thing. Your parameters always should be traced first. You should do a, and you see over here we're running it with x, so we're doing my class dot something parentheses x. So this x is matching up with a. So in the stack trace, when we're doing a, we're going to put it to be whatever the value of x is. So 10, right? Because x was 10, we're putting x in here and we're tracing that. So you want to look at this as whenever you run something, you're tracing it with all the stuff that you gave it in terms of arguments and things like that. So we have a is 10, and then another variable, x, because we have our own x in here. This x and this x don't clash at all because this one is contained entirely within something. So we make x over here 5, and then see we're returning x plus a. Now this doesn't have a row inside of our stack frame because it's not being assigned to a variable. We only make rows in the stack frames for when we're assigning things to variables. So instead, we just go back to z and see x plus a, which would be 10 plus 5, which would be 15. So we are returning 15. We go back to z, and then over in our stack frame, we go back to z, and we put 15, right? Because z is the return value of doing my class dot something. And my class dot something x is returning 15. Lastly, we need to do return to variable to show where did this 15 come from. So you go ahead and click this button right here, return to variable, and you see these green dots that show up now in the main. We go ahead and select the 1 for z. And now we've shown that z is 15, and that 15 comes from running something. Let's go ahead and cross all of our stack frames out. And that is done. We are now done with this stack trace. All right, so now we've finished that trace. I have a practice problem that I want you to do to assess whether you understand what's going on. So I have over here this example code. You can go ahead and pause the video, copy this down however you need, and give yourself, I'd say 10 minutes to trace this, and try not to cheat, because if you run this through IntelliJ or you run the code and see what the outputs are, you're really just sort of shooting yourself in the foot. Go ahead and take 5 to 10 minutes to go ahead and trace this. All right, so we've gone ahead and traced this now. So I'm just going to go over my solution and why it looks the way it does. So we make our main stack frame. We declare the X, the Z, and the B, and the W, right? X starts as 10. Z starts as the return value of running something to, which returns just 15. And so does B. And you notice I put a something 1 here. This was a bit of like a red herring. It's not being run at all, so there's no stack frame for something 1. There's 2 of them for something 2, because it's being ran twice, but none for something 1. Anyways, moving on from that. So we have X, Z, B, and then W, which is Z plus X, and that would be 10 plus 15, which is 25, minus B, which is 15, which brings us down to 10. So we have W and it's 10 now. So then we go ahead and reassign the variables. So X is now 25. Z is now whatever the value at W was, which was 10 at that time. So now Z has been updated to be 10. And now W is 5. And one thing you might question is, why are these stack frames empty for something 2? It's because we declare no parameters and no local variables, which means there is nothing to trace in there, but you still want to have these boxes to show that you understood where each thing was coming from. So now that we're done with that, we can cross it out, and that completes our solution for this problem. And just a recap of some of the things we've learned today. When you're doing a stack trace, make sure when you run a method, you trace the arguments and the local variables, some exceptions being the main method. Make sure you only make stack frames for methods that are actually ran, and make sure you always cross out your stack frames and use return arrows wherever appropriate. If you have any questions, feel free to reach out to your TAs, make a post on Piazza, or talk to your professors. Thanks for watching. Have a great day.